Welcome to Decision Trees and Random Forests in Python. Today, you will learn how computers make decisions by asking yes or no questions using decision trees. You will also see how random forests combine many trees to make even smarter choices. By the end, you will build and use models to help computers predict things in the real world. Running the cell now. After each example, pause and try it on your own in Jupyter. Remember to like and subscribe if you are finding this lesson helpful. What is a decision tree? A decision tree is a flowchart-like structure. Each point, or node, asks a question. The tree splits into branches based on answers. They help computers pick or predict an answer, step by step. Running the cell now. Think about when you play 20 questions. That is a lot like how a decision tree works. Let us build a simple decision tree together and see what it predicts for a new example. This starts by loading a tool called Scikit-learn. It helps with decision trees. We set up some simple numbers as our data. Our features are tiny lists, showing 2 input numbers at a time. Our labels tell the tree if each example is a 0 or a 1. We create a tree model that can sort things into categories. We train the tree model on our data. Training means it learns patterns. When the model sees 2, 2, it tries to guess if it is more like 0 or 1, and prints the answer. Running the cell now. Try changing the values in X or Y and see how the prediction changes. The data, features and labels. Features are facts or numbers we know about each example. Labels are the outcomes we want to predict. For example, features could be test scores, labels could be if a student passed or not. Running the cell now. Can you think of features and labels from your own life? List a few in your notebook. This code creates a tiny dataset with 1 score per student. We want to know if each student should pass or fail. Our tree model learns from the given data. Training again means it looks for patterns. Now, we use it to predict if a student scoring 60 would pass, based on examples it has seen. Running the cell now. Try other scores as input for prediction. What does your tree guess for 50? A visual look at trees. Decision trees are easier to understand with pictures. Let us plot the student example tree. Running the cell now. It really helps to see the rules as splits. Drawing them can make your tree feel alive. This code helps us draw our trained decision tree. We use matplotlib, a popular plotting library. We set the size so it fits nicely. It builds a tree plot, showing how the tree splits scores and decides who passes or fails. Now, the plot shows up, and we can see the decisions as a map. Running the cell now. Look at each branch. Which scores lead to the pass? Which go to the fail? This time, each example has both a score and an extra credit flag. More features mean the tree considers more facts per student. We tell the tree to look at this bigger dataset. The tree learns again, now using both columns. We predict if a student with 60 and extra credit will pass. The answer uses both features now. Running the cell now. Try students with other combinations of score and extra credit. Splitting data for training and testing. It is important to test the tree on new data to see if it learned well. We should split our data into a training set and a testing set. Let us do that now. Running the cell now. Testing on new data lets us check if our tree is really learning, and not just memorizing. Here, we use a tool to split our data with a special method built into Scikit-learn. We have more data points now, with a mix of scores. Labels still show who passes or fails. We break up our data into two groups, for training and for testing. The tree is trained on the first group. We check how well the tree does on the testing set. We print the accuracy. This is the percent of test cases the tree got right. Running the cell now. Change the test size and see how your accuracy changes. Testing helps you trust your model. If you are enjoying this, please like, share, or leave a comment below the video. Safe access and handling missing data. Sometimes your data has missing values. You can use extra tools to fill gaps or skip missing data. Let us see what happens when a value is missing. Running the cell now. Missing data can trick your tree. Handle it early for better predictions. In our dataset, one score is missing and marked as none. Our labels are still there. We start training a tree as usual. But we wrap the training step in try. This means we can catch any errors. Scikit-learn does not let us train if data is missing, so we get an error. We print the error to see the message. It reminds us to check for missing data. Running the cell now. Practice, try replacing none with an actual number and run again. Errors are chances to double-check your data. To clean up missing data, we use a tool called Simple Imputer from Scikit-learn. We tell it to use the mean, which means average, to fill in missing spots. It fills the gap, creating a new dataset with nothing missing. We create and train the tree on the fixed data. If you see this message, it worked. No more errors with missing values. Running the cell now. If you have missing data in your own projects, try out a mean, median, or other strategies to fill it in. Making decisions, questions at each split. Each node in a decision tree asks a yes or no question. Good questions split the data clearly. Trees decide on the best questions by themselves during training. Running the cell now. When you look at the diagram, read out the questions at each node. Practice thinking like a decision tree. Here, we set a limit on how deep the tree can grow. Max_depth equals 1 gives us just one question splitting the data. We train the tree on several scores marked pass or fail. We plot the tree to see what the main question is. This is a good way to understand what the tree thinks matters most. Running the cell now. Try changing max_depth to 2 or 3 and see new splits appear. Limiting depth is called pruning and helps with overfitting. We load a real dataset called iris, which has information about different flowers. The tree learns from many features, not just one or two. We create and train the tree on the iris flower measurements. Now we predict the labels for the first 5 flowers. This shows how trees scale up to bigger, real examples. Running the cell now. Look up iris.data and iris.target in your notebook to see the raw numbers. A random forest is a team of decision trees. Each tree gets a slightly different view of the data. The model combines the decisions of all the trees to make its final guess. We train the forest using our student scores, just as before. When we predict, the forest votes, and the most popular answer is what comes out. Running the cell now. Try changing n_estimators to use 50 or 100 trees. Does this change your results? Here we check what both models predict for 3 students. We use both the simple tree and the random forest, then print out the results to compare. Try looking for scores where tree and forest might disagree. A random forest is usually more stable and accurate because it reduces random errors. Running the cell now. Find a score where the tree and forest differ. Which result do you trust more? Why? Overfitting means memorizing the training data but not generalizing to new examples. Random forests help avoid this problem. We test both models using our test set. We print the accuracy for the tree and then for the forest. See if the random forest does a better job overall. Running the cell now. If you get different numbers each run, try setting the random underscore state for repeatable results. Random forests shuffle things each time they build trees. Setting random underscore state ensures you get the same result every run. This is useful for learning and for sharing code. We train the forest and see the prediction for 60 again. Running the cell now. Try leaving random underscore state out and you might notice different outputs. Extra, tuning trees and forests. There are many ways to tune your models, like changing max underscore depth, n underscore estimators, or split rules. Experiment with these to get better predictions for your data. Running the cell now. Try setting max underscore depth to different values in your decision tree. Try n underscore estimators with 1, 10, and 100 in forests. Mini project start. Can you beat chance at predicting Titanic outcomes? Let us put it all together with a famous real-world example, the Titanic. We download data about passengers, including age and fare paid. We pick just 2 features to keep it simple, and fill in any missing spots. We set the labels to who survived and who did not. We train a decision tree with a simple shape to avoid overfitting. Finally, we predict who survived for the first 10 people in the data set. Running the cell now. Look at the predictions and try using more features, like datasets or Scikit-learn, for even better results. You can test the model with your own age and fare. The code asks you to enter your age and how much you paid. Your answers are used together as features for prediction. The tree predicts if you would survive, based on your numbers and the dataset. Running the cell now. Try out different ages and fares to see what your chances are. Could you use this model to make choices in real life? Think before you trust a model's decisions. Instead of just one decision tree, let us use a random forest and see if it does better. We build the forest with 50 trees and some limitations to avoid memorizing. We train again on the same features and labels. This prints predictions for the first 10 people, just as before. Running the cell now. Compare these predictions to the single tree. Which model do you trust more? This time, we build a tree using only age as the feature. We still fill in missing ages with 0. We train a small tree and make predictions for the first few people. Try swapping in fares alone or even a new feature of your own. Running the cell now. Practice, add datasets or Scikit-learn as features and see if things change. Not all data works. If you give a string where it expects a number, the model will not work. We wrap this in try, so the notebook does not break. This tries to train on text instead of numbers. The model gives an error, which we print here. Always check your data type, numbers for numbers, words for categories. Running the cell now. Practice, change 20s to 20 and try again. Can you fix the error? This special property shows what features your tree found most useful. Higher numbers mean more power in the tree's decisions. Running the cell now. Run this for any tree in any dataset to peek into its thinking. Recap and next steps. You learned how computers use decision trees and random forests to make predictions. You handled missing data, tested accuracy, and explored model tuning. Try these tools on your own favorite dataset. Like this lesson? Please like, share, or subscribe to our channel for more. Comment below if you tried your own dataset. Running the cell now. Nice work today. To learn more, watch the next video or check out extra notebooks. And do not forget, like, subscribe, and leave your questions in the comments. Thanks for learning with Python. Try a practice project using trees or forests on your hobby or work data. And do not forget to like, comment, subscribe, and share this video with friends. See you in the next lesson. Running the cell now. Great job completing this beginner journey. Take a break and then try a challenge from the comment section.